So welcome to the revision video for iGCSE Physics. This is just one whole topic. There are some more videos which are individual subsections, but this is for if you finish the entire topic. So there are 8 videos in the series. If you like and enjoy, please subscribe. Okay, this is a iGCSE little introduction for section 2B mains electricity. Equations, we're looking at power in watts is current in amps times voltage or potential difference in volts. Typically for iGCSE, they use the term voltage. I hate it. I like to use the term potential difference, but they do write it an awful lot, so you can use it. Power then is IV, or power is VI typically. Energy transferred in a circuit in joules will be current times the voltage times the time. You need to do that in seconds and convert from minutes or hours. E equals IVT or E equals VIT. And of course, you've got power there. P could be here. So energy is power times time because power is the rate. Quantities and symbols, we need to introduce the ampere, the coulomb, the joule, the watt, the ohm. Time, of course, you should know, and volt, V for voltage, or typically we should call it potential difference, clearly. We need to know about the 3-pin plugs, so the earth wire, the green and yellow, the neutral, the blue, which stays neutral, the live, which oscillates as an alternating current between plus or minus 325, but is actually a DC equivalent of 230 volts at 50 hertz. And we've got a fuse. We need to know about what fuse do, the structure of the plug and the materials it's made of. We also need to know about safety devices, so circuit breakers, the term double insulation, which means basically things with a plastic case do not need an earth wire. Fuses as well, and ground, a symbol, and then of course you've got all these electrical symbols. Now initially you only need the basic ones, but when you get to year 11, you will need to know them all. We also need to know about the national grid. So national grid that transmits and transforms power from high or low current to high or low potential difference to reduce energy losses in transit. So power loss is I squared R. So as I transmit my power, power is power. Hopefully what you're trying to do is deliver the same amount of power that you start out with. But what you can't do is actually change your power to increase it, but you can alter the potential difference or current by using transformers to reduce these power losses. So there's a little bit about that. You need to know the difference between alternating current and direct. So AC goes 2 ways, DC just goes 1. So there you go. That's mains electricity, quick summary. Okay, so this is a quick introduction for iGCSE. Section 2C, energy and voltage, it's called. It's really potential difference. Quantities and symbols you need to know. Current is the ampere, charge is coulombs, energy is measured in joules, power is watts or joules per second, resistance in ohms, time is seconds, and voltage, the volt, V, or potential difference. Quantities then, so it's joules are how we measure work or energy. So you've got 1 joule or 1 Newton meter when we apply a force of 1 Newton to an object to move it a meter. That's a joule. That's all it is. It's like moving an apple. You could think of a meter across a desk. The ampere, so we think of coulombs, so each little electron has a tiny bit of charge. All of it adds up if we take 6.25 times 10 to the power of 18 of them. And if all of those pass per second, we call it 1 amp or 1 coulomb per second. Resistance, that's a measure of how much a wire resists flow of current. You find it by the ratio of V divided by I is R, or V equals IR, via. And we measure it in ohms. Omega is the symbol. What did you say? Yes, the SI unit of power equivalent to 1 joule per second in an electrical circuit where the PD, potential difference, is 1 volt and the current is 1 amp. So P is VI, 1 watt is 1 joule per second. Equation-wise, similar ones to coming up before. So power, current times voltage. Energy transferred is current times voltage times time. We must convert to seconds. Energy in joules is also charge times voltage or potential difference. E is QV. And we said about V equals IR already. Now, what's quite important is thinking about the formulas for series resistance and parallel resistance. So series resistance, the total resistance, you just add up the 2 resistors. But in parallel, 1 over, or the reciprocal of resistance, is 1 over the resistor 1 plus 1 over resistor 2. The key bit is, if the resistances are different, the current will be different in each branch. We've got some clever little rules for series and parallel circuits. So in series, the current is the same everywhere, but in parallel it splits according to resistance. In series, the PD, the energy is shared, whereas in parallel, the components on that branch get all the energy for the power supply. In series, we said the resistance adds up as a simple total down the bottom corner, or in parallel, it's lower. So if we have more pathways, we have a lower overall resistance, sort of pictures like this between brighter bulbs, dimmer bulbs, that kind of thing. We need to know our component graphs. So we've got thermistor. So resistance versus temperature, it drops rapidly, non-linear. Same for light intensity. So similar idea with these symbols. Non-ohmic conductors, so we're thinking of diodes and light bulbs. You get a funny little graph where it curves, it kind of switches on at about 0.65 volts, and in reverse direction, pretty much nothing flows. An ohmic conductor, so like a resistor at a constant temperature, straight line graph of IV. Now, what's really weird is actually at GCSE, they often plot the graphs like this with the V across the bottom. Now, that's because that's the variable that you change in the experiment. However, if you plot them this way, the gradient is actually 1 over the resistance. So if I plot it the other way around, I put V up the y-axis and I on the x-axis, then the gradient, it will curve the other way, and the gradient is the resistance. So that's worth thinking about. So there you go. That's the main bits for energy and voltage. Okay, so this is a little introduction to section 2D, electrical charge for iGCSE physics. So we have quantities and symbols. We're back to the current, ampere, charge, coulombs, energy in joules, power is measured in watts or joules per second, resistance measured in ohms, symbol omega, time in seconds, and voltage or potential difference in volts, V. Prefixes, so sometimes because charges, there's not a lot of charge on individual particles, we sometimes deal in smaller units. So we've got millicoulomb, micro, nano, and pico. So 10 to the minus 3, minus 6, minus 9, minus 12. You need to be familiar with those ideas. Key ideas, so positive and negative electrostatic charges are produced on materials by the loss and gain of electrons. So it's just a particle out here. Some students drift into talking about neutrons and protons. Don't do that. We're just talking about electrons. So there's no effect on the atomic structure of the atoms, but a material could be positive or negatively charged overall by the removal of one of these particles. So we either get attraction or repulsion. Now, the particles themselves, we can either deal in relative charges or we can deal in the actual charges. So it's an actual charge of minus 1.6 times 10 to the minus 19 coulombs. But for this purposes, we can think in terms of simple stuff. And the mass is obviously the electron is a very small particle, 1/1840th of the mass of a proton. So it can be moved about. We need to talk about or know the ideas about how sparks can be dangerous as electrons move between objects to a lower potential or ground. So it might be like, you touch a doorknob and electrons can transfer to ground, or it could be the other way around for the charges. We need to know about a whole series of applications. So rods and cloths, so rubbing rods and cloths and how the charges move, Van de Graaff generator, thunder clouds, sparking from the cloud down, or vice versa. Photocopy and inkjet, how we can control with electrostatically charged plates where the droplets fall on paper. Fueling a plane, that's dangerous if you don't discharge your static. Paint sprayers, smoke precipitators, and flower shoots and gold leaf electroscopes. So all of that is in your static charge section.